Hi guys, welcome to our next video of turbines. In the last video we covered impulse turbine and in this one we'll study about reaction turbines. Let's see what is a reaction turbine. A reaction turbine is a type of turbine that develops torque by reacting to the pressure or weight of a fluid. The operation of reaction turbines is described by Newton's third law of motion. Action and reaction are equal and opposite. In a reaction turbine, unlike in an impulse turbine, the nozzles that discharge the working fluid are attached to the rotor. The acceleration of the fluid leaving the nozzles produces a reaction force on the pipes, causing the rotor to move in the opposite direction to that of the fluid. Let us now see its working. A reaction turbine has rows of fixed blades alternating with rows of moving blades. The steam expands first in the stationary or fixed blades, where it gains some velocity as it drops in pressure. Then enters the moving blades, where its direction of flow is changed, thus producing an impulse force on the moving blades. In addition, however, the steam upon passing through the moving blades again expands and further drops in pressure, giving a reaction force to the blades. The reaction turbine is of two types, Francis turbine and kaplan turbine. First, we will see about Francis turbine. In Francis turbine, water flow is radial into the turbine and exits the turbine axially. Water pressure decreases as it passes through the turbine, imparting reaction on the turbine blades, making the turbine rotate. Let us now look at the working. Francis turbines are generally installed with their axis vertical. Water with high head pressure enters the turbine through the spiral casing surrounding the guide vanes. The water loses a part of its pressure in the volute spiral casing to maintain its speed. Then water passes through guide vanes where it is directed to strike the blades on the runner at optimum angles. As the water flows through the runner, its pressure and angular momentum reduces. This reduction imparts reaction on the runner and power is transferred to the turbine shaft. Let us look at the components of Francis turbine. First is penstock. Penstock is a pipe and are considered to have large size diameter. The source of water is coming from the reservoir and it takes the water to the turbine runner. The second is guide vane mechanism. Guide vanes are also known as wicket gates. The main function or usages of the guide vanes are to guide the water towards the runner. The third component is casing. The runner is completely enclosed in an airtight spiral casing. The casing and the runner are always full of water. The next is draft tube. For discharging of water, a tube or pipe with gradually increasing area is used for the water discharge from the turbine exit to the tail race. Increasing area of the tube is known as draft tube. The next component is runner. Nearly 20 to 24 blades are attached to the runner. When the water strikes these blades, they move in a particular direction, which in turn helps in generating the power. Next, we'll study about Kaplan turbine. The Kaplan turbine is a propeller type water turbine which has adjustable blades. The Kaplan turbine was an evolution of the Francis turbine. Its invention allowed efficient power production in low head applications, which was not possible with the Francis turbine. Let's have a look at its working. With help of the guide vane, the water enters the guide vanes are aligned to give the flow a suitable degree of swirl. The swirl is determined according to the rotor of the turbine. The water flow from the guide vanes are passed through the curved surface which forces the radial flow to direction of axial. The swirl is imparted by the inlet guide vanes and they are not in the form of free vortex. With a component of swirl in the form of axial flow are applied forces on the blades of the rotor. Due to the force, it loses both angular and linear momentum. Let's study the components of Kaplan turbine. First is hub. For Kaplan turbine, the shaft of the turbine is vertical. The lower end of the shaft is made larger and is called hub or boss. The vanes are fixed on the hub and hence hub acts as a runner for axial flow turbine. The rest of the components are similar to that of the Francis turbine, which are draft tube, casing and guide vane mechanism. Now let's have a look at a very important topic, the difference between impulse and reaction turbine. The first difference is that in impulse turbine, we only use the kinetic energy to rotate the turbine, while in reaction turbine, both kinetic and pressure energy of water is used to rotate the turbine. In impulse turbine, water flows through the nozzle and strike the blades of the turbine, whereas in reaction turbine, water is guided by the guide blades to flow over the turbine. Next difference. In impulse turbine, the pressure of water remains unchanged and is equal to atmospheric pressure during the process, whereas in reaction turbine, the pressure of water is reducing after passing through the vanes. Next difference. In impulse turbine, all pressure energy of water converted into kinetic energy before striking the vanes, whereas in reaction turbine, there is no change in pressure energy of water before striking. The last difference is, in impulse turbine, we use it for large head and lower flow rate. Pelton wheel is an example of impulse turbine, whereas reaction turbine is best suited for higher flow rate and lower head situation. So that's all for today's video. If you liked it, please like, comment and subscribe to Bunker Study Point. Keep watching. Thank you.